Okay, this is just to go through the homework. Okay, so question 1. Okay, we want to know which term of the arithmetic or linear number pattern that looks like this is equal to negative 13.5. Okay, so to get which one is equal to negative 13.5 or negative 13.5, the first thing we can notice is since it's arithmetic, there will be a constant difference between them. The constant difference should be negative 5 over 4. So minus 1 minus a quarter, negative 5 over 4. This is also negative 5 over 4. Then I use the fact that I know a formula for arithmetic number patterns, and I can use the fact that now I know what this constant difference is, and I can quickly see this would be my formula, but I can use some information to solve for A. I don't need to overcomplicate it. A will always be equal to my first term, n minus 1 times negative 5 over 4. Okay, so then I can multiply this out if I really wanted to, and I can get that negative 5 over 4n plus 5 over 4 plus a quarter. In other words, negative 5 over 4n plus 3 over 2 is my general formula. To get which one is equal to 13.5, I would just set my general formula down, negative 5 over 4, n plus 3 over 2, and then term 13 would be equal to this. Okay, and then term 13 we know is equal to 13.5. No, oh no, I'm not asking for term 13. I had a brain fault there. I'm asking which one is equal to 13.5. Okay, so if I go back, okay, so I'm not asking this. This is how you determine 13. I'm asking which one is equal to negative 13.5. I can substitute this in, and I can say that, let me just quickly get if it's the right pen. Yep. Okay, I can say this would be equal to negative 5 over 4n plus 3 over 2. So then I can go and solve for this. I'll quickly show you how. So this is negative 27 over 2. Okay, I can take this over to that side as well. Minus 3 over 2 is equal to negative 5 over 4n. So minus 15 is equal to negative 5 over 4n. To solve for this is easy. I just divide both sides by this number. In other words, it's going to be negative 15 over negative 5 times 4 is equal to n. The solution is 12. The memo is slightly different. It had a mistake there. Okay, n must be equal to 12 over here. Okay, so the 12th term, okay, is equal to negative 13.5. You can test it as well. Second question. Determine the sequence if it's arithmetic if the fourth term is negative 6 and the 11th term is equal to negative 34. Okay, so fourth term negative 6, 11th term negative 34. I would just say, okay, we know it's arithmetic, so we know that the general formula must be equal to this, which means that the fourth term must be equal to this, okay, times my difference. So in other words, a plus 3d. Okay, and this is equal to negative 6. I also know that the 11th term must be equal to this. So I know that this is equal to negative 34. Now, it's a simultaneous equation. Just call this A and B. Okay, and I can use this to solve. I can either get A alone and then just determine A in terms of D and use that to sub into the other equation, or you can use any method where you set them equal to each other or any way you prefer. Just scroll a bit and you'd get that this is D equal to 4 or negative 4. So my difference must be equal to negative 4. Okay, if I've solved for my difference, that's half the way there, I can then just solve for A. The easiest way is, since we're already busy with a simultaneous equation, let's call this thing C, and we can just say sub C into star. Okay, and we can just get that A is equal to negative 6 minus 3 times negative 4. And then we can say A must be equal to 6. Okay, to get my sequence from here, because I think it asks you to get the sequence, determine the sequence, we don't need to use the formula all the way. We can just use the fact that we know now the first term must be 6, the difference must be negative 4, so 6 minus 4 minus 4 minus 4 dot 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 dot. Okay, so this would be how to solve that. Okay, our third question I can do over here. So question number 3 asked us, okay, given that t5 is equal to x minus 2, t6 is 2x minus 6, and t7 was 4x, right? Minus 8. Let me just see if I'm correct. 4x minus 8. Whoops. 4x minus 8. Okay, so then we know the first difference, which is, the first difference must be constant. It's a constant because it's arithmetic number pattern. So these two things must be equal. So in other words, 2x minus 6 minus x minus 2 must be equal to 4x, whoops, keep doing that, minus 8 minus 2x minus 6. Okay, so then what we get is, from here we can just distribute in and we get 2x minus 6 minus x plus 2 is equal to 4x minus 8 minus 2x plus 6. On this side we're left with 2x minus 2. On this side we're left with x, and this is minus 4. If we take all the numbers to one side, or all the variables to one side, I get this. All the numbers to the other, I get this. X must be equal to negative 2. This one also had a mistake in the memo. This is the correct answer if you substitute it back. And the question actually asks us to determine x and to determine the sequence. Okay. So to determine the sequence, we know x is equal to minus 2. So we can get term 5. Okay, so it's going to be term 1, 2, 3, 4, 5, and they've given us 6 and 7 as well. 6, 7, and it continues after that. We know 5 is equal to x minus 2. This one is equal to what? 2x minus 6, and this one's 4x minus 8. Okay, so let me just check that I was correct there. Yep, okay. So if I substitute in negative 2, this must be negative 4. If I substitute in negative 2, this must be negative 10. If I substitute in negative 2, this must be negative 16. So you can see our constant difference is negative 6. We can actually solve it in a different way as well, but it's easy enough to see. Then this must be equal to 2, this must be equal to 8, this must be equal to, so I'm just going in reverse. So if I'm minusing 6 in this direction, I'm going to plus 6 in the other one. So 14 and 20. Okay, this is definitely the case. We can see it works out this way. Okay, this is the easiest way to solve it. You can go and solve it in a different way where you can say, okay, let's try and determine Tn and say, okay, Tn is equal to a plus n minus 1 d, and we know the constant difference is 6, so a plus n minus 1 times negative 6. Yep, and then we can substitute in like term 5, for instance, and say that this thing must be equal to negative 4, a plus, and then it becomes minus 24. If I take this over, a must be 20. So I get exactly the same answer if I try and do it this way. Okay, so you can just do it the quickest way. This is 20, right? Okay, just in case my ugly writing there fooled you. Okay, so there we go. The next thing we can do is question 4. Okay, let me just check if I have space. Okay, I'm going to try it down here. I'm going to clear for question 5 because it's a slightly bigger one. Question 4 is quite small. So question 4 is 1, 4, 9, 16, 25. This one is an obvious pattern. Okay, I'm going to show you if you can't figure out an obvious pattern like this, what you can do. But obviously this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So we don't even have to overthink this. Tn would just be equal to n squared. They want us to determine term 12. So this is my answer. Okay, 144. Okay, so if you really wanted to and you're unsure of your answer, which in this case I doubt, you could go and look at the first difference, and we can see the first difference is not constant, but the second difference is, this is going to be a quadratic number pattern. And then you can go through the effort of saying this is equal to 2a, this is equal to 3a plus b, and this one is equal to a plus b plus c, and you can solve it. Okay, it's not necessary for this one. Let's look at number 5 where it will be necessary. So I'll just clear this. So for number 5, it is definitely necessary to do. Well, maybe you're clever enough to do it without it. I think it's easier to do it with this. So if it's 575, 528, 483, 440, we can look at the constant difference and see that in fact it's not the same first difference, but it is the same second difference, right? So negative 45 minus 47 is going to be 2. Okay, so what's very important is to determine this is always going to be the one on the right minus the one on the left. So it's negative 43, the one on the right minus the one on the left. So it's negative 47. To get this, and then obviously for 483 minus, so it's negative 45. To get the second difference, we look at this one minus that one. So always right minus left again. And we can say negative 45 minus 47 is going to be minus 45 plus 47, which is in fact positive 2. Okay, so don't make a mistake there. Always right minus left. Now we have some information. This, and this are going to be equal to some things. We know this will be equal to 2a. This will be equal to 3a plus b. and this one would be equal to a plus b plus c. Okay, so we can list that information. 2a would be equal to my constant second difference. Okay, 3a plus b would be equal to the first of the first differences. In other words, term 2 minus term 1. And the last thing I know, let me just list it down here, is that a plus b plus c would be equal to 575, or in other words, our term 1. Okay, now we can use this information to solve. Okay, so it's not written out the most neatly there, but I'll solve it neatly. So let's solve it on the right hand side of this. Okay, so I'll restate my information. 2a is 2, 3a plus b is negative 47, and then a plus b plus c is 575. So I'll always start by trying to solve this one first, then go down, solve this one, then this one. Because this one's the easiest. We can just say a would obviously then be equal to 1. I just divide both sides by 2. If a is equal to 1, then 3a, right, would become 3 times 1 plus b is equal to negative 47. So b must be negative 50. Okay, cool. That's easy to solve. The next one, I can then just say, okay, but then 575 must be equal to a is 1, b is negative 50, plus c, negative 49. If I take it over, this must be my c value. So it must be equal to, what is that, like 600 and something. Okay, so my brain is slow today. So it would be 615 plus 9 is going to be like 624. Let me just see if I'm mistaken there. So 624 then, and what we get is we have solved for both A, B, and C, or all three of them, not just both. Then we can state our general formula, which is always Tn is An squared plus Bn plus C. So we can say this is then just n squared minus 50n plus 624. Okay, so we've got our general formula. Was that our first question? Yes, our first question was to get the general formula. So this is the solution to A. Now the next question wants us to use this in order to determine which term would be equal to 0. To determine that, I just set my general sequence equal to 0. Okay, and you can see this is a quadratic equation then. Okay, so I'm just going to use the quadratic formula to solve this. And say n would be equal to minus b plus or minus square root of b squared minus 4ac over 2a. So in other words, I get minus 50 is positive 50, plus or minus, I think this is 2,500, minus, and then it's 4 times 1 times 624. Okay, and it's over 2. So let me just quickly use a calculator to get the two solutions for this one. Okay, so I get this thing is just 4. Wait, it's 4. I didn't take the square root. Okay, so underneath here it's 4, so it's plus or minus 2. So it's going to be 48 over 2 or 52 over 2. So these are going to be, let me just scroll to the side. Doesn't want to listen to me now. Come on. There we go. Okay, so we're going to get either it's 24 or it's 26. Okay, so this thing might have two answers. Let's quickly see if it makes sense. So we're saying term 24 and term 26 are my answers. Okay, if we substitute them back into my formula, which is n squared minus 50, so now in n's place I can just write 24 squared minus 50 times 24 plus 624, or 26 squared minus 50 times 26 plus 624, 24. Let's see if those two do in fact equal to 0, so I'm just going to plug them in a calculator. Okay, great, it does make sense. Both of them do equal to 0, so I know these are the terms. So I'm going to write term 26 and term 24. Those are my answers. Okay, I'll just have about enough space to do another question.